Hello dear students, once again I welcome you in digital learning session of analog communication. So today we will see the next lecture, that is on the topic Laplacian distribution PDF, or the PDF whose function looks like Laplacian distribution. So this function is given by fx is equals to a e to the power minus b mod x, or we may write this function as a e to the power minus bx for x greater than 0, or a e to the power plus bx for x less than 0. So this is the representation of Laplacian distribution function. So we may plot this function like that. For x greater than 0, so this is the x-axis. So for x greater than 0, it is exponential decrement. So e to the power minus bx, and for x less than 0, its value will be a e to the power bx, means exponential increment. So this is the representation of Laplacian distribution function. So now for this function, this variable a and b having some relation, a is equals to b by 2. So if I assume is equals to alpha, so if I assume this a is equals to alpha or b by 2 is equals to alpha, so we may represent this function, or we may represent this function like fx is equals to b by 2 e to the power minus b mod x. So in some book this function is represented by fx is equals to some capital X by 2 e to the power minus capital X small x. Okay, so that will depends upon the notation for this Laplacian distribution function. So now I am calculating the statistical averages for this Laplacian distribution function. So our first statistical average is mean. That is m1. So mean is represented by minus infinity to plus infinity x dot fx dx. So now in our case, b by 2 e to the power minus b mod x. So we may write this, since b by 2 is constant, so I bring this outside and I divide this whole limit from minus infinity to 0 and 0 to infinity. So for minus infinity to 0, this function will be e to the power minus b of, since minus infinity to 0, our x will be minus x. So this is minus x dot dx. Here we will have dx plus 0 to infinity x e to the power minus b plus x dot dx. So this will give us b by 2 integration minus infinity to 0 x dot e to the power bx dx plus integration 0 to infinity x dot e to the power minus bx dx. So now I perform this integration, so that is b by 2. This we can solve by integration by part. So first function is x, second function is e to the power bx. So first function integration of second function is e to the power bx upon b, and for the limit minus infinity to 0 minus integration of differentiation of first function. So differentiation of x is 1 and integration of second function. So second function is e to the power bx. So its integration will be e to the power bx upon b dx. So this is about the first. And for second, so same for second, first function is x, second is e to the power minus bx. So first function, integration of second function for the limit 0 to infinity minus integration from 0 to infinity, here also minus infinity to 0, and differentiation of first function is 1, second function, integration of second function is e to the power minus bx upon minus b dot dx. So in this case, in this complete expression, this function is for upper and lower limit, this function will be 0, and similarly this function will be 0. So we will get b by 2 is equal to, since this function is 0, so 0 minus this will be b by we have 1 by b as a constant, and again integration of e to the power bx, so that will give you e to the power bx upon b for the limit minus infinity to 0, plus this function is again 0, minus minus plus, this is 1 by b is constant, take it outside, e to the power minus bx upon minus b, and for 0 to infinity. So now b by 2. Now if I substitute this limit, I will get for upper limit it is 1 by b, and for lower limit it is 0. So I have minus 1 by b multiplied by 1 by b. That means this function will give us 1 by b, plus for this is 1 by b, and when I substitute this upper limit I will get 0, and minus of lower limit, that is 0, so minus of minus will give you plus, so 1 by b, so that is b by 2 minus 1 upon b square plus 1 upon b square. So ultimately this mean for this Laplacian distribution function will be 0. Now we will solve the next statistical average, that is square mean, given by m2. So m2 is minus infinity to plus infinity x square b by 2 e to the power minus b mod x dot dx. Now mathematically I shift this limit from minus infinity to plus infinity to 0 to infinity. So for that I have to multiply by factor 2, and this limit is now from 0 to infinity x square dot b by 2 e to the power minus b mod x dot dx. So again this b by 2 is constant, so bring it outside, this 2 will become cancel, so we will have b, and this we have to solve by integral. So for the limit 0 to infinity, this mod x will be plus x, so directly we may write 0 to infinity x square into e to the power minus bx dot dx. So now apply the integration. So constant is b, first function is x square, so first function integration of second function, that is e to the power minus bx upon minus b for the limit 0 to infinity, minus integration of differentiation of first function, that is 2x, and integration of second function is e to the power minus bx upon minus b for the limit 0 to infinity dot dx. So now this portion is again 0 because of the presence of this x square. So b 0 minus, now for this 2 and minus b, 2 upon minus b is a constant, so bring it outside, so this minus minus will become plus 2 by b, integration 0 to infinity x dot e to the power minus bx dot dx. Now again we have to integrate this function, integration by part. So here this 0 is nothing else, so b and b cancel, so 2 is constant. Integration first function, integration of second function e to the power minus bx upon minus b for the limit 0 to infinity, minus integration of differentiation of x is 1 and integration of minus b e to the power minus bx is e to the power minus bx upon b dot dx. So again this will be 0, so you will get 2, and this minus and minus b will give you 1 upon b outside, so 1 upon b, and since this integration is from 0 to infinity, so this will give you e to the power minus bx upon minus b for the limit 0 to infinity. So when you solve it, you will get 2 upon b square. So square mean for this Laplacian distribution function is 2 upon b square. Now our third statistical average is variance. So variance is given by rho square, so that is m2 minus m1. So m2 is 2 upon b square minus m1 is 0, so our variance will be 2 upon b square. And fourth is a standard deviation, so I am solving here. Fourth is standard deviation. So standard deviation is square root of variance, so that is square root of 2 upon, since variance is 2 upon b square, so this will give you root 2 by b. So this is all about the statistical average quantity for the Laplacian distribution function. So if you have any doubt, you may ask or you may message your query. I will try to solve your queries. So thank you.